All right. All right. Thank you, Jonathan, for the introduction, and thank you, Meredith. Can everybody see my slides?
Yes, they're visible. They're good.
Okay. Okay, great. I will try to minimize the slide view on the side. Unfortunately, the setup that I have doesn't allow me to display the slide view. So I'm going to talk about federal technology transfer at the USGS. I'm have a poll question here for you. And I don't have the ability to create polls in Zoom because I'm not allowed to download the Zoom client. So if you could just indicate with a thumbs up emoji or a raised hand emoji, true or false. If it's true, I am very familiar with federal technology transfer. All right, I see some thumbs up. Okay, great. So not everybody's familiar with this. So I will proceed to explain what technology transfer is about if you're a federal laboratory. But a lot of what I'm talking about will also be very applicable for non-federal entities. So we're going to talk about technology transfer as a journey. Technology transfer is a journey that transfers federally developed technologies and capabilities to other entities. And we can do this through quick adoption and provide great impact. And so shown here is just a list of activities and items to consider when we want to embark on federal technology transfer. We have innovations, we might have laboratory capabilities, intellectual property figures very importantly in technology transfer, and commercialization assessments to see whether or not a technology is viable for transfer. We'll talk a little bit about cooperative research and development agreements and how we can license our intellectual property. Altogether, doing technology transfer from the federal laboratory to the private sector provides great impact to state and local governments, private industry, and the public at large. So all federal agencies that conduct research and development at a certain level are authorized to engage in federal technology transfer activities. So I'm going to take you through the process step by step. First, I'll introduce USGS and technology transfer at USGS. I'll describe the laws that authorize technology transfer from the federal sector to the non-federal sector. I'll explain the benefits of technology transfer, how we implement technology transfer authorities at the USGS, and then I'll provide you a few examples of USGS technologies. So first, about the USGS, many of you may already be familiar with the USGS. This is a small agency within the Department of the Interior. It was created by an act of Congress in 1879. USGS provides science for a changing world, which reflects and responds to society's continuously evolving needs. As a science arm of the Department of the Interior, the USGS brings an array of earth, water, biological, and mapping data and expertise to help support decision-making on environmental, resource, and public safety issues. The mission is as shown here. The USGS monitors, analyzes, and predicts current and evolving Earth system interactions and delivers information at scales and timeframes that are relevant to decision makers. The USGS is a primary federal source of science-based information on these areas, including ecosystems, land use, energy and mineral resources, natural hazards, and water. Okay, so already mentioned technology transfer a number of times, so I thought it might be helpful to pause here momentarily to provide some definitions, because there are, many ways to define technology transfer, and this is how we define it within the federal laboratory system. Technology transfer is a way to describe the overall process and activities that are used by federal agencies to transfer their knowledge and provide access to their technologies to fulfill private and public needs. Technology transfer is a means of spreading such information, knowledge, and expertise to the broader society. And this is done to accelerate innovations, advance the nation's economic, social, and environmental well-being, and increase our nation's economic competitiveness. Now, there are two approaches to technology transfer that federal agencies, or actually for that matter, any entity out there can undertake. You could make information immediately available to the public through publications, web postings, professional conferences, social networking, and other forums. Another approach is the one that we're going to cover here in this briefing, and that is the approach in which we might protect from public disclosure certain types of information, such as inventions or proprietary information, perhaps that another non-federal entity might provide within the scope of a technology transfer agreement. This is done to enable and encourage the investment of funds and resources from a non-federal partner, especially private sector corporations or companies. And that's done when it's needed in order to mature and commercialize the discovery or the invention into a market-ready product. Such protection does provide potential non-federal partners the ability to recover their investments and make a reasonable profit before the patent or patent license expires. So while these two approaches to technology transfer may appear to be opposite to each other, depending on the circumstances, one or the other, or perhaps even both, may lead to a more effective dissemination of the technology in question. Okay, I have another poll here, another true or false question. And if you could just indicate if this is true, indicate with a thumbs up. All federal laboratories are required to engage in federal technology transfer activities. Okay, I see, I think I see one thumbs up. Okay, so I assume that everybody else thinks that's false, that we're not required to engage in federal technology transfer activities. Well, okay, so here are the laws that authorize federal technology transfer. And there are a number of statutes that were passed by the Congress beginning in 1980. I'm not going to go through all of these in detail. I am going to highlight two of these authorities, which are the primary ones that are applicable to federal laboratories. And just in summary, the Stevenson-Weidler Technology Innovation Act of 1980 established technology transfer as a mission of the federal government. So yes, it is required to do technology transfer when you do a certain amount of R&D at your agency. The Bayh-Dole Act of 1980 permitted universities and nonprofits to obtain title to inventions that were made as a result of any grant or financial assistance award. The Federal Technology Transfer Act of 1986 made technology transfer a priority for all government employees, and it also authorized cooperative research and development agreements and authorized the federal government to license out its patents for a royalty stream. And I'm going to talk about that authority in more detail later. The Executive Order 12591 facilitated access to science and technology for state and local governments and academic institutions. And then the National Technology Transfer Advancement Act provided FLC, that stands for Federal Laboratory Consortium, with funding, and also improved some of the provisions in CRADAs that are more attractive to private industry. So the Federal Technology Transfer Act of 1986 does contain a policy statement by Congress, and that is that it is the continuing responsibility of the federal government to ensure full use of the results of the nation's federal investment in research and development. So the federal government shall strive where appropriate to transfer federally owned or originated technologies to state and local governments, as well as to the private sector. So the Federal Tech Transfer Act of 1986 also provided a charter for the Federal Laboratory Consortium for Technology Transfer. This is an organization that's composed of all federal laboratories, and they provide a lot of resources to help laboratories implement their own technology transfer programs. At the end of the slide presentation, I have a slide with links, and there is a link to the FLC, as well as other information resources. This act also enabled federal laboratories, that's government-owned, government-operated laboratories, to enter into cooperative research and development agreements. It also authorized federal laboratories to negotiate license agreements with private sector for patented inventions and intellectual property that originate from the laboratories. The act also required that federal agencies share any proceeds from patent licenses that come in as royalties with the employee and inventor. And it also provided for the exchange of personnel, services, equipment, and intellectual property between federal and non-federal entities. It also provided the ability for laboratories to grant or waive rights to inventions and intellectual property. The Executive Order 12591 was written to ensure that federal labs assist universities and the private sector by transferring technical knowledge developed at the federal labs. It also emphasized the government's commitment to technology transfer and urged federal laboratories to enter into cooperative agreements to the limits permitted by law. It also promoted commercialization of federal inventions by requiring laboratories to grant to its contractors title to their inventions that are developed in whole or in part with federal funds, as long as the government is provided a royalty-free license to use it on behalf of the government. And then it also required consultation with the Office of the U.S. Trade Representative for any CRADAs or agreements done with foreign companies or foreign governments. Okay, so that's pretty much it for the authorities that apply to all federal laboratories, all government-owned and government-operated federal laboratories. I'll now discuss another legal authority that the USGS has that authorizes collaborations. These collaborations are more along the lines of conducting projects. There is no provision for intellectual property under this authority. So if the project is really just a fairly straightforward collaboration, we can use this authority. We don't have to use the tech transfer authority. Other federal agencies may also have similar authorities. So it's definitely worthwhile to work with your office of counsel or your solicitor's office to determine if there are any other authorities that would authorize collaborative agreements. So for USGS, we have the Organic Act, which is codified at 43 U.S.C. 36C. And it's a fairly broad authority. It allows the USGS to accept contributions and also to conduct projects in cooperation with other entities, federal, state, tribal, private sector, and academic. We use what we call collaborative agreements when we're using this authority. And we can also cite this authority in interagency agreements. So, we've done many agreements with other federal agencies that cite this authority, as well as probably the more commonly known authority of the Economy Act. Under this authority, advance payment is required for non-government entities, but we can also do agreements that have no funding changing hands. The agreements can be for all in-kind contributions by both parties. I have a note here that says no funding to non-federal parties. We anytime you have funding going from the federal government to a non-federal entity, there actually even to another federal entity, there is a separate legal authority that governs that, and of course, for the most part, the regulations are quite different as well. For contracts, that would be the federal acquisition regulations. So the benefits of technology transfer are as shown here. At the USGS, we use technology transfer to help leverage our research programs and capabilities by partnering with the private sector, as well as states and tribal entities. And we can offer these partners access to our expertise, access to specialized laboratory facilities. We can also protect proprietary information that's provided to us from another party. We can share existing patents and licenses and share an intellectual property that results from the effort. Protection of information is available under certain conditions for up to 5 years. And another benefit is the royalty stream that can be realized by law. A portion of the royalty does have to go to the inventor, employee inventor. Another portion could go to the laboratory. And then if there's a very large number of royalties that come in, there are additional provisions in law for how that's distributed. So how we implement tech transfer at USGS is as shown here. We primarily use agreements. Partners may include federal agencies, for-profit agencies, state, local governments, academic institutions, and even international entities. The agreement, the statement of work in the agreement must indicate that there's some mutual benefit to both missions of both parties. Non-federal parties may provide personnel services, intellectual property, equipment, and funding. The federal laboratories can provide everything else except funding. So as I stated earlier, whenever you have funds leaving the government, it's subject to federal acquisition regulations, and it would need to be done through a contract or other mechanism. So these are the agreement types, and we're looking here at the first item you see here is the Cooperative Research and Development Agreement. That's a fairly long agreement. I believe our template, our CRADA template, is on the order of 20 pages in length. It has exhaustive provisions on intellectual property and licensing. We use the CRADA for efforts that appear to be, either have a lot of potential to develop intellectual property, such as inventions and patents. We can also use CRADA to help commercialize technology. And again, as stated earlier, both parties can exchange personnel, services, equipment, know-how, expertise, and the non-federal party can contribute funds. Then we have something called a Technical Assistance Agreement, TAA, and that's a much shorter agreement than the CRADA, and it's used when the likelihood of having intellectual property or the need to commercialize something is very, very small. It's more of a project level agreement. And that's a fairly brief agreement. I believe it's on the order of 5 or 6 pages. And then we have the patent license agreement, which we use to allow another entity to use an invention that's been patented. And go ahead and march on through here. We have another even shorter agreement than the technical assistance agreement called the Facility Use and Service Agreement. All right, I see a hand raised. Jonathan.
Yeah, I have a question from earlier.
Uh-huh.
Again, here it's the license and patents. So it's possible to essentially transfer the license through the technology transfer authorities, but that's not my question. Or clarify that if I was wrong. But if you have like a unit of technology, just say like it's a widget, a technology widget, it's a physical asset that sits on the ground, can that be transferred? So like, say it's sitting in a municipality and the government's done using it, can that just stay in that municipality and then be taken over and owned by them?
Okay, so yeah, the answer is it depends. If it's if it was a property controlled item, when I say it depends, if it was a result of a tech transfer agreement, say between the municipality and your agency, and you develop the agreement, or excuse me, the equipment, or they procured the equipment, and you procured the equipment, I guess. And at the end of the project, then you want to, you can actually transfer title to that equipment to the municipality, right, if there's if there's no need for it.
Yeah, and I think that's something we're looking at, and within IARPIC this is a very interesting mechanism. If we're developing research with local communities, if at the end of the project, through these technology transfer authorities, can we leave the technology in place for them to continue to use? So I think it depends, is your answer.
Yeah. As long as you have an agreement in place. Yeah, if you started out with a tech transfer agreement, then under that authority, the equipment can be allocated to the other entity.
Great.
So, but yeah, that is definitely that's a great question, and definitely something to to ensure that your office of counsel concurs with that as well. We have I've seen situations where we have provided equipment to a university, after the study was done, and so.
Okay, cool, thanks.
Yep. Okay, you're welcome. And so, yeah, actually, how much time do I have left? Because I know we started a few minutes late, but I don't want to cause the,
right.
I don't want to run past the schedule.
Let me just see the agenda, because I think we can give you a little more time. You were allotted for 30 minutes, but whatever time we run over here, we're just going to take out from the discussion at the end. So if you want to have more fluid discussion now, that'll be fine as well.
Okay, all right. So I'll aim for about another 8 minutes then. It looks like that would bring me at 30 minutes. Okay, thank you, Jonathan. All right, so facility use and service agreement is something that the USGS uses to provide laboratory services or access to specialized equipment at laboratories. For the most part, it's providing laboratory services. I have here, you'll see under the FUSA, it states here, no undue competition with the private sector. And that is just to make sure that we're not in violation of OMB regulations that state that the federal government should not be in competition with the private sector. So that means that if you have a laboratory capability that is a fairly common lab capability that any lab, any private sector lab can do, you should not be using the FUSAs, the agreements to to sell those capabilities to someone else, because that would be competing with the private sector. On the other hand, if you have very highly specialized equipment and it really is unique, then that's great. There's no issue with competition with the private sector. And material transfer agreements are also used to transfer materials and samples to outside entities. And then we have non-disclosure agreements that might be used to discuss information that needs to be kept protected. I do note here that federal employees are covered under the Trade Secrets Act, under 18 U.S.C. 1905, from disclosing proprietary information that's provided to them, and it's marked as such. So with or without a non-disclosure agreement, as a federal employee, if you receive information that's marked as proprietary, you are bound by this law to not disclose it. So, with or without a non-disclosure agreement. Technically speaking, we wouldn't even need to have a non-disclosure agreement because we have the Trade Secrets Act. But most companies do want an agreement in place, or a state, might be a state. And so we have developed templates for that purpose. So this slide just depicts the overall strategy that we use to develop technologies and transfer the technologies. We will start out with, it might start out with research or perhaps a capability that's further developed into expertise, software, databases, perhaps unique materials or equipment, specialized equipment that's needed. And we can use technology transfer mechanisms to further develop those ideas or those capabilities. Then we can then engage in collaborations with outside entities using various agreements, including the non-disclosure agreement and the CRADA. And then finally, results will be published, patents would be applied for, licenses of intellectual property could be made to private industry. Now, this is just a snapshot of intellectual property at USGS. So now I'm shifting into more of the USGS specific projects and examples. So currently we have roughly 40 patents or 50 patents that I think it's more like 40 patents that are active. If you add up the numbers on this pie chart, it exceeds that number because some science subcategories might fit, or several science categories might fit a single patent. But that just gives a snapshot of the various, the broad categories of science that we engage in. And again, another way to categorize our patents is as shown here. And I'm not going to dwell on this in the interest of time. This information is on our external website for patents, and that link will be provided at the end of the presentation. This is, I'll just run through this quickly. This is a list of the USGS patents, as I've mentioned. Okay, now I'm going to talk a little bit about some concrete examples that we have of technology transfer. This is a successful technology transfer, and it's still ongoing. This is the Shake Alert system, which is an early warning system for earthquakes. And it enables notifications to go out to devices, including cell phones or computers, or devices that are used to maybe control, doors, fire station doors or elevators. And it just provides a few seconds of warning so that there's hopefully enough time to take cover and, in anticipation of more destructive waves that result from an earthquake. USGS has been working on this system for many years. And the USGS has also worked with many other partners, including state and local government agencies and universities. The system was, it's not patented, but it's the name of the Shake Alert name is trademarked. And we do have some ability to license out the trademark. The licensing arrangements that we use for Shake Alert do not bring in any income. There are no royalties because the federal government does not have a legal authority to collect royalties on trademarks. The previous mentioned legislative authorities on federal technology transfer does authorize the federal government to take in royalties from patented technologies. But this is trademark, so there is no royalty stream. However, we have a huge interest in ensuring that the quality of the licensees is appropriate, so that we ensure trust and high quality for licensing out the Shake Alert feeds. Okay, now this is another example that I'd like to share, and I'll do this very quickly in the interest of time. This is a ballast water tank treatment system that is used to help prevent the introduction of invasive species from foreign lands that are carried in ballast tanks on ships from being released into, into U.S. waters. Control of invasive species is a worldwide problem, and it has resulted in billions of dollars of damages affecting both the ecosystems and the commercial industries. Ships that transport goods around the world can carry invasive species in ballast water. The discharge of ballast water after transporting cargo can release non-native species into foreign ports. Big problem, as everybody knows, is probably aware, is in the 80s, in the late 80s, the zebra mussels were introduced into U.S. waters, and they have resulted in a great deal of damage. So our scientists, we had two scientists, Barnaby Wanton and Noah Adams, from two of our ecosystem science centers at the USGS, came up with a solution for ensuring that a more effective means of disinfecting ballast tanks from ships could be done. So they had done a lot of work with trying out different biocides, as well as trying different mixing methods to ensure that the biocide is evenly distributed throughout the tank. And the invention was patented in 2017. In addition, the USGS entered into a cooperative research and development agreement with a marine engineering firm to conduct further tests on this. And these collaborations took place over a number of years, from 2008 to 2014. And it has resulted in an effective, at least at the bench level, an effective method for disinfecting ship ballast water tanks. It's actually, it was submitted as for an award, and it won this year. So later this month, this technology will be honored at the Federal Laboratory.
Oh, did we lose our Sharon?
Oh, I'm here.
Oh, okay. Your video
Did you
cut.
lose my slides? Can you still see the slides?
No, but I see you. Well, why don't we just take this opportunity to, transition, and we can take a question now, or we probably need to get on to the other agenda items if people don't have questions.
Absolutely. Yeah, the next slide was a conclusion slide, so
Okay,
that's
I really liked the marine example. So I come from BOEM, and I can think of examples like we do bubble curtains for acoustic mitigation. There's all sorts of cool technology always coming out. So that was a great concrete example for me, and I'll look forward to reading more about that.
awesome. Great.
So
All right.
you
So
have a
yeah,
question for Sharon? I mean, I had another question, but this is kind of a little snarky. I come from an agency, we do most of our science through procurement, so the federal acquisition regulations. And one thing we always do is we try to tie scientific deliverables to the payments we make to contractors so that we can enforce the terms of the agreement. When you're partnering with a private corporation and there's no money being compensated to them, how do we make sure that we're each holding up our end of the agreement? Are there mechanisms in the Technology Transfer Act analogous to this, the way we do things in the FAR?
Boy, that's a great question, Jonathan. And one thing that I've learned about the federal technology transfer world is it is a very different animal from, acquisitions. It is, it's more of a business to business deal almost, rather than a federal, than a contractor to contracting relationship. What we do have in these agreements is a termination clause. And, occasionally it is true that, you start off with a partnership and things don't always work out. So you can always invoke the termination clause and terminate the agreement. But, that's been a rarity in my experience at the USGS. We find that, most of the partnerships actually work out quite well, and you don't need to have, a big stick like you do, when you're paying, when you're sending money out to a contractor. You do need to keep close tabs on, on their activities to ensure that you have a deliverable. So these are, by its name, cooperative really does indicate a good faith effort on both parties' part to do the right thing. And if it doesn't work out, termination is an option.
Yeah, there's always that.
Right.
All right. Well, and if there's no other questions, I'll let
I
it.
see that Anne has her hand raised.
Oh, great. Thank you.
I don't want to create a rabbit hole. If you're trying to go on to something else that's.
No, I mean, we have Sharon here now. We can always
Okay.
talk about this other stuff.
Yeah,
later.
so Jonathan, you brought up something earlier about, because I'm participating in navigating the new Arctic projects, and I don't have I could possibly have an example of this. So if we're using federal funds, Sharon, is that technically, this is applicable to that, right?
If you're using federal funds, you mean are you providing funds to someone else?
Go ahead. No, I'm just saying we're required to partner. As Jonathan said, being able to transfer what we're developing to communities. Well, in this case for NAA, we're required to include them as part of the research team, and they're supposed to guide us. So what happens? I mean, I hopefully will have MOAs or MOUs or letters of support with my community partners, but if there's something that needs to be, something that we develop, they're going to have a buy-in, right? And,
Right.
and
So
with the CARES principles, what happens if they don't want this stuff to be, you know what I'm saying, Jonathan?
I'm not sure, this is exactly the example I was thinking of for IARPIC. We're trying to do co-production, develop scientific projects in collaboration with local communities. And so if the only agreement you have with them is a somewhat informal MOA, and you're looking for something that's a little more formal, these technology transfer cooperative agreements might be very suitable.
Yeah, but what if they object? Because if they're applying the CARES Act, they want sovereignty and proprietary say-so on, depending on what it is. I don't know what it might be, but
and Sharon can answer, but I think I'm involved in this enough. I can provide the preview. What Technology Transfer Act allows you to do is protect their data sovereignty for up to 5 years. So I think it might be very commensurate with exactly the issues that you're raising.
okay.
yeah,
Right.
so yeah, a lot of this too, Anne, depends on the authority that you're using to engage with this other entity. Sounds like if it's under financial assistance.
No, it wouldn't be financial assistance. No, well, Jonathan can explain it through the IARPIC lens, but the NAA, we're supposed to actually include them as research team members, which I try and do. But so far, I don't have any outputs that would probably come into play, but I could, so just trying to think ahead here.
Yeah. Always a good thing. It's so much easier to head off any conflicts if you look far enough.
So for instance, I do community-based monitoring. This is a good example. I hate to go down this rabbit hole, but maybe this might apply. So to be fair to the community, I do this whether it's indigenous or local residents, it doesn't matter to me. It's just their data, right? If I'm collecting data from their community, it's their data. So I have to get either a study permit or permissions after the fact to use it and distribute it. That's the way I look at it. So I have tried to figure out a way to do that with my communities in some sort of formal paper trail that they have administratively. So I'm covered, I guess, right? But so far, I haven't had any problems with that, but I could see it possibly, because we're doing modeling with the data and it's, creating new modeling scenarios and software stuff. So who knows?
Yeah, at the very least, you should have some kind of an MOU in place.
Yeah.
And something, a written agreement. And then if given the software aspects to it, it's probably a good idea to have an agreement that speaks to any intellectual property that might be developed and who owns what and who can use it. Yeah, absolutely.
Yep, I agree. Okay, just thought I'd go down that path there for a minute.
I think that's a whole nother topic that we're going to have to, plan a future meeting for. That's one thing we're good at here in IARPIC. We can always come up with new meeting topics.
All right.
So thank you, Sharon, so much for that thorough presentation. I think that sets this team off on a good path. We kind of have a foundation now, and we'll carry this forward. And if we have any questions, I hope we can reach out to you and continue to seek your advice.
Yes, absolutely. Yep, I'm happy to help. And the complete slide deck does have the list of websites and, places to get more information. And I also included some contact information for myself and two of the principal technology transfer staff in my office. So we're
Right.
all happy to provide, any advice and answer any questions.
Thank you so much.
Okay. All right. Thank you.
Yeah, so the next item on our agenda, we should have enough time for Mark to present his slides. And let's just get started with that part. And we hopefully have 5 minutes or so to discuss it afterwards, maybe not. Go
All
ahead.
right, we'll see what we can do. So welcome everybody for here. So this part of the meeting is more getting the admin area to it. And specifically, as we've shifted into the sort of like reorganized IARPIC, we wanted to take some time to sort of explain to people how we got here and where we are going with this technology foundational team. So to start with, in December 2021, the White House Office of Science and Technology released the Arctic Research Plan. This research plan provides this high-level research strategy framework for the Arctic. Within the Arctic Research Plan is defined priority areas and foundational activities to achieve these goals. So the priority areas get into community resilience and health, Arctic systems interactions, sustainable economies and livelihoods, risk management, and hazard mitigation. Underneath that, with the foundational activities, and the key here is that a new foundational activity was added with technology, innovation, and application. Within that, or beyond that, we then have the Arctic Research Plan is met through development of implementation plans every 2 years. So the current biennial implementation plan is from fall 2022 to fall 2024. The figure on the lower right is the cover photo from that biennial implementation plan. And the timeline has the fact that this implementation plan was released in November, and then it's good through October 2024, during which time shortly beforehand, it will be updated, and then a new biennial implementation plan will be released. There was a launch for this in November, and then a month ago, the co-leads for the different teams got together both online and in Anchorage to sort of set forward this path meeting the Arctic Research Plan. So the new organization plan for IARPIC involves priority area collaboration teams, or PACs, foundational activity collaboration teams, or FACs, and communities of practice. This organizational structure replaces the previous community teams and self-forming teams that was the structure of IARPIC prior to this change. So the technology, innovation, and application FACT adopted the previous polar technology self-forming team. So here is a chart showing the different priority collaboration teams, as well as the foundational activity collaboration teams and the communities of practice. So we see our 4 priority areas, the 5 foundational activity teams, and then the 11 communities of practice. So let's now back up to how we got to this point, is to see that the originations of this sort of effort comes from the Polar Technology Conference, which was held annually from 2005 to 2016. The PTC went on hiatus after 2016 due to the need of a dedicated funding source and a planning team. It returned in March 2020 with a meeting in Boulder, Colorado. And then the outcomes from that meeting was to, one, rebrand from Polar Technology Conference to Polar Technology Community, and a desire for year-round communication and activities. To establish the year-round communications activities, we then created a self-forming team within IARPIC to serve as this conduit of communication activities. For various reasons, including COVID, the self-forming team was fairly quiet for about 1.5 years. And then we had an inaugural meeting in May 2022. We've also had focused collaborative meetings with atmosphere, marine ecosystems, and glaciers and sea level collaboration teams, where we were able to identify areas of implementing technology in those teams and had a joint meeting. And now this PT community self-forming team was shifted to the tech foundational activity team within this implementation plan and Arctic research plan. So we've also then been tasked with creating a work plan for 2023. And this has then been completed by myself, Lisa, and Jonathan. And Meredith's role is a representative of the IARPC Secretariat to make sure that she answers all our tricky questions. So our vision for this upcoming year is we want to develop a community of participants, representative academic, government, private sectors with investments in polar technology, and that these participants will include those working in both the Antarctic and the Arctic. And we appreciate the Antarctic participants that have joined us in this meeting. And we want to refine the scope of the focus of activities. Exactly what are we looking at when we say the technology, foundational activity within the deliverables of this larger implementation plan and the larger IARPC. Then the third item that we want to get into is establishing communication channels, common interests across the IARPC teams and communities of practice to continue on with these collaborative meetings. So the meetings that we'll be having going forward is the first Thursday of March, June, September, and December, having our quarterly core meetings where we get into presentation of the community, overarching theme, topic of common interest, then also getting into the business activities such as I'm covering right now. Then beyond that, we'll be connecting up with the other teams to have collaborative meetings with common interest and technology focus. So that's where we're at and where we're going forward with this. We wanted to just take a time to basically lay this out for the people that have joined along the way. As certainly as co-leaders, we've found it a interesting adaptation to this new organization and understanding our different roles and plans going forward. And with us is our ability to share it with everybody. And that's all I have. You're muted, Jonathan.
Oh, I just spent the last minute we had on mute. So anyways, I was going to ask, does anybody have any questions for Mark or any other comments for the good of the order? So let's see, do we have any hands raised? Thank you so much, everybody, for joining us. This was really informative meeting, and I look forward to having these quarterly meetings where we can exchange core team activities and information. So thanks for joining, and we'll see you again next quarter, hopefully. Thank you.
Thanks.
Bye-bye, everybody. Thank you.